So here is an example on determination of eigenvectors of a matrix. So we have taken a 2 cross 2 matrix and it has been asked to find the eigenvectors of this matrix A. So we know that an eigenvector is a column vector which satisfies this relationship. Okay, A is this matrix, X is the eigenvector, lambda is the eigenvalue of this matrix. Okay, so we have to find a vector which satisfies this relationship, a column vector which satisfies this relationship. So for that, first we have to determine the eigenvalues of this matrix. So for that, we have to form this matrix first. Okay, so this is, as I have already done in the eigenvalues video, it will be 5 minus lambda 4 1 2 minus lambda. We have to determine the determinant of this matrix, which will be the characteristic equation. The characteristic equation is A minus lambda I determinant is equal to 0. Okay, so let us first find its determinant, which is 5 minus lambda into 2 minus lambda minus 4 is equal to 0. That implies 10 minus 5 lambda minus 2 lambda plus lambda square minus 4 is equal to 0. That implies lambda square minus 7 lambda plus 6 is equal to 0. This is in the form of a quadratic equation. So it will be lambda square minus lambda minus 6 lambda plus 6 is equal to 0. See, minus 1 minus 6 is minus 7, minus 1 into minus 6 is 6. Okay, so it satisfies the quadratic equation format. So it will be lambda into lambda minus 1 minus 6 into lambda minus 1 to 0. So the two eigenvalues are lambda is equal to 1 and 6. These are the two eigenvalues. Okay, so now we have to find out the eigenvectors corresponding to these two eigenvalues. It means for each eigenvalue there will be a separate eigenvector. Okay, so let us erase this part. Okay, let us write down the eigenvalues. Lambda is 1, 6. Okay, so for the determination of the eigenvector, let us first assign a column vector which is the prospective eigenvector, and let us name the two elements of the eigenvectors as x and y. Okay, so we have to find the value of x and y such that ax is equal to lambda x. Okay, or we can say that a minus lambda I into x is equal to 0. Okay, both these are the same. A minus lambda I into x is equal to 0. This is one way, this is the other way. Okay, so you can approach by any one of the following methods. Either you find ax is equal to lambda x, you compare on both sides, or you find out this a minus lambda I x is equal to 0, because ax is equal to lambda x came from this. Okay, so a minus lambda I, here we already have a minus lambda I. Let us put the value of lambda. First let us put 1. So it is 5 minus 1 is 4. Here it is 4, 1, 1, and the eigenvector x, y, it is equal to 0, it means we have a 0 matrix of order 2 cross 1, okay, a column vector with all the elements 0. That is meant by this being 0, a minus lambda I into x being 0 means this, okay. So it is 4x plus 4y is equal to 0. This is one set of equation. Another one is x plus y is equal to 0. So in both the cases it is x is equal to minus y, okay, in this case, in this case. So if x is equal to 1, y will be minus 1. If x is equal to minus 1, y will be 1. So these can be the two eigenvectors, okay. If x is equal to 2, y will be equal to minus 2. If x is equal to be 3, y will be equal to minus 3, and so on, okay. So this is one of the eigenvectors and this is the other eigenvector. It can be like this, okay. So one set of eigenvectors corresponding to 1 we have determined, okay, 1 minus 1, okay. Now let us determine the eigenvectors corresponding to the eigenvalue 6, okay. So same, we have to substitute lambda with 6. Five minus 6 is minus 1, this is 4, this is 1, and this is 2 minus 6 is minus 4, okay. And this is x and y. So it is minus x plus 4y equal to 0 matrix of order 2 cross 1. Minus x plus 4y is equal to 0, and x minus 4y is equal to 0. So in both the cases it is x by y, okay, x by y is equal to 4, 1 by 4, okay. In both the cases it is x by y is equal to 4 by 1. So if y is equal to 1, then x is equal to 4, okay. This is one eigenvector, okay. If y is equal to 1, x is equal to 4, so 4 and 1, this is one eigenvector. Similarly, if we put y as 4, then x will be 16. If y will be 4, then x will be 16. Similarly, if we put y as 2, then x will be 8. If we put y is equal to 2, x will be 8. So this relationship, this proportionality relationship must hold, it must be correct. Then you can put any value of x and y. So here we have put the simplest values, we have put y is 1, x is 4. So here are the two eigenvectors corresponding to the two eigenvalues 1 and 6. There can be many eigenvectors, but we have to pick the simplest ones. So for lambda is equal to 1, one of the eigenvectors, okay, one of the eigenvectors is 1 and minus 1, and for lambda is equal to 6, one of the eigenvectors which we have determined is 4 and 1. Okay, so this is how you determine the eigenvectors of a particular matrix. First to determine the eigenvalues, then you check the relationship Ax is equal to lambda x or a minus lambda I into x is equal to 0. Okay, So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.